Let's wait for less than a few seconds and then we'll start. Currently at 10:22. طيب بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Welcome to EE21. So today's lecture will be the 8th lecture. And before we start, there are a few announcements that I would like to make. The first one is homework 1 is posted and it's inshallah due this Thursday at 11:59 p.m. And to submit the homework, please use Gradescope. The instructions are here. So you need to scroll down until you reach join a class or sign up for a class as a student. Then you fill in the information. And once you go there, you will find you can upload your homework. As far as for quiz 1, it's going to be inshallah tomorrow during class time. The material will be 1.1 to 2.5. طلال.
يا دكتور هل السلايدات تكفي للمذاكرة كويز بكرة؟
Okay. Let's start. You're not. Okay. Start.
Can you hear me, doctor?
Okay, good.
I just said, are the slides enough for the quiz tomorrow?
You need to study the book because you need some exercises.
Because I don't have the book yet.
Okay. So, does everybody have the book? Do you guys have the book? Please.
Online, doctor.
There is the soft version.
Okay. Okay. So the slides will be the basics of you master the slides. You need the textbook for more information on like solving the problems, etc. Okay. So moving on. Let's go over what we've done in the last class. If you recall, in the last class, we were attempted to solve the following circuit, or to construct a systematic way of solving the following circuit. So just applying KCL, KVL, and Ohms Law on this circuit will make it very complicated. So we will end up solving inverting very large matrices. So we notice here that we need to count, for example, the essential node. And just a reminder about essential, we need to solve for the essential branch counts. So just a reminder for essential branches can be derived from the fact that an essential branch is a branch that connects to essential node. So this brings the question is, what do we mean by essential node? Essential node is a node where 3 or more elements are connected. Taking, for example, node B here, we have 4 connections, 4 branches out of it. So this is an essential node. In contrast, node A is not an essential node because it connects only 2 elements. So in order to solve for the entire circuit, so we need to find the current in each branch. For example, we need to find the current that flows in this branch. We need to find the current that flows in this branch. We need to find the current that flows in this branch and as well in this branch. So we have a lot of branches. In this case, we have 10. And we need to find the current in each one of them. So this would require solving a 10 by 10 matrix or 10 equations with 10 unknowns. The inversion of 10 by 10 matrix is not straightforward. You cannot use it with most calculators, and definitely you don't want to use it if you want to. You don't want to invert the matrix using your hand calculations. So we said, well, instead of focusing on the current on each branch, let's focus on the current on each essential branch. So just a reminder, by essential, what do we mean by essential branch? Is a branch where we connect two essential nodes. For example, E is here is an essential node. So this branch, the one that passes through R5, is an essential branch. Take, for example, G here is an essential node. So this branch is an essential branch. This branch is also an essential branch because it connects two essential nodes. So just shifting the focus from branches to essential branches reduce the number of equations from 10 to 7. Because here I have 4 essential nodes out of 7 nodes. So going back to the issue that we faced, we said that if we want to solve it in a direct way, then we need to apply KCL and KVL. So if we apply KCL, KCL will give us 6 linearly independent equations, which means which means that we need one extra equation to solve for the circuit, to solve for the currents in each branch. So in order to find that extra equation, we need to use KVL. And with KVL, with 6 equations from KCL, 1 equation from KVL, we can solve for the essential current branches. Notice here the following: that you need to invert. You reduce the number of equations, you reduce the dimension of the matrix from 10 by 10 to 7 by 7, but still inverting 7 by 7 matrix is not a straightforward approach. So let's try to find an alternative approach. It turns out that if you introduce intermediate variables, usually if you introduce something in the middle, sometimes this will complicate things. But here, the good thing about it is if you introduce intermediate variables here, you can simplify the calculations, and then you go to Ohm's Law, and you utilize Ohm's Law to find the exact specific branch current that you're interested in. So it turns out there are 2 methods. The first one is the node voltage method. And this method, you are introducing a new variable, which are the node voltages. So the essential node voltages. For example, here, we're not interested. I mean, if we're looking here into this equation, we're not interested in finding the voltage at this node, which we call Vx. This is not something that we are interested in usually. But it turns out if we try to find Vx and as a node voltage here, maybe this one Vy, then we can use Ohm's law to find the current passing through R1. So the introduction of just these intermediate variables will reduce the number of equations from BE, which is the number of essential branches, to NE minus 1. NE is the number of essential nodes. So here we have 7 branches and 7 essential branches and 4 essential nodes. So if we use node voltage method, we introduce a new variable. The equations that we need to solve is going to be 3 equations with 3 unknowns. So inverting a 3 by 3 matrix is something is much simpler than inverting a 7 by 7 matrix. And in fact, you can do it with your calculator. all of your calculators can do it. So this is the first approach, and this is what we're going to cover in today's lecture. And maybe next lecture or the lecture after that, we're going to consider mesh current method, which is another method. Here, instead of actually solving the the new variable, the intermediate variable that we're going to introduce is the mesh current, which is, for example, here, the current that's passing through this element. And if we introduce the mesh current, we're going to reduce the number of equations from BE, which is the number of essential branches, to BE minus NE minus 1, which is, in this case, we'll have 4 equations. So notice here, if we use, for this specific circuit, if we use mesh current, if we use node voltage method, which is the method that we're going to study in a moment, then we're going to reduce the number of equations from 7 to 3. If we use mesh current method, then we're going to reduce the number of equations from 7 to 4. So you may ask yourself, well, this discussion suggests that a node voltage method is better because it reduces the number of equations from 7 to 3 compared to a mesh current method. It turns out this is not always the case. It depends on the circuit. So in some circuits, the mesh current method is much simpler or much easier and much faster, while the situation is the exact opposite in some circuits, meaning that the node voltage method will give you the easiest and the fastest way of solving for the circuit. So any question about this general idea? Again, the goal for this discussion is to appreciate the what's coming next. So this is just like a motivation on what's coming next. Any questions, Shabab? Okay, I'm assuming it's clear. طيب. So let's start with the node voltage method. So again, node voltage method is a technique that solves for the essential node voltage. Using, here it's very important, we are using Kirchhoff's current law. And we're trying to find the essential node voltage using KCL. So there are some techniques or there are some general steps for applying the node voltage method. So the first one is, and the most important thing is, you need to count the number of essential nodes. And we'll see, we'll explain these steps in an exercise, in an illustrative exercise. Then you need to choose one of these and you set it as a reference. Remember, the voltage is actually the potential difference. So if I tell you what's the potential difference between point A and point B, you would kind of like, what's the potential difference at point A? So you should ask me, what will be the reference point here? So we need to choose one of these essential nodes to be the reference point. We usually choose the one with the most branches. Then you would notice that in one of these essential nodes, say like you have NE essential nodes, one of them is you chose as the reference point, so you know the voltage. So if you choose the reference point, you set it to 0. You said like, this is the essential node where the voltage is 0. So this leaves you with NE minus 1 equations to describe the circuit. Then if you want to find, then in this case, once you determine the number of equations that you need to just apply KCL. So in applying KCL, you assume all the currents are leaving the node. Before actually we start, let me just go over one way of writing Ohm's law. So if I give you this circuit, if I tell you this is node A, this is node B, this is the value of the resistance R, and I'm asking you to find, say, like the current here, I, that's flowing in this direction. Then from Ohm's law, you see that I will be VA minus VB divided by R. So VA minus VB is the potential, is the voltage drop across the resistor, and R is the value of the resistance. So this is one way. This is one way of applying Ohm's law. If I reverse the direction of the current, then you should get something like this. In this case, the current is, assuming that the current and the voltage has, the current and the voltage have the current is flowing from the high potential point to the low potential point. So in this case, VB minus VA divided by R. Okay. Is it clear, Shabab?
Oh, yes, it is.
Okay.
Yeah, I think so.
Okay. So now let's illustrate how to apply node voltage method. So we have the following circuit, and in the following circuit we need to actually apply the node voltage method. Let's see how to apply the node voltage. So let's go back to the steps. So the first one is we need to count the number of essential nodes. So here I have, this one is an essential node. This one, the entire point here is an essential node. And this one is also an essential node. So I have the number of essential nodes is 3. So this is the first step. I counted the number of essential nodes. So let me write this one: 1, 2, 3. So I'm done with the first part. So I need to choose one of these nodes and make it a reference node and set the voltage to be 0. So again, here we usually choose the node with the more branches. So in this case, it's a clear choice here. So it's node 3, because node 3 has 4 branches. Node 1 has 3. Node 2 has 3. So clearly node 3. And I'm setting this one to 0 volts. Okay, so I'm done with the second option. Yes, Abdullah.
Yes, doctor, if I have 2 nodes with the same number of branches, which one should I choose?
In this case, you usually, it's better to choose the one that connects to the voltage source.
Oh.
Okay. Now the third thing here is to I need NE minus 1 voltage equation to describe the circuit. So here I have NE is 3. So number of equations is 3 minus 1, which is 2. So I only need to solve 2 equations to unknowns. So these 2 equations are the voltage at node 1. Let me call it V1 here. This is V1. The voltage at 2, this is V2. So V1 is the high potential that is at the node. The low potential, which is the 0 potential here, is at the reference node. Similarly, V2 is the same. So now I need to apply KCL, assuming all the currents are leaving the node. So let's start with node 1. So here, let me use, for example, I have 3 currents leaving that node. I have this current, and this current. So I'm assuming all of them are leaving the node. So for the first one, the one that's flowing to the 10-volt source. Yes, Ahmed. Ahmed.
Doctor, yes. Doctor, could you please repeat number 3? I didn't understand it clearly.
Number 3 is the number of equation is 3 minus 1 equals to 2. Is that one?
Yes.
Okay. So for node voltage, you'll notice that because you have 3 essential nodes. So you need to find the voltage in all of these 3 essential nodes, صح?
Yes, it is.
If you choose one of them as a reference and you set the voltage to 0, you assume that the voltage is 0. How many unknowns now?
2, because it's cancelled.
Because one of them you found you assume the value of that.
Yeah, thanks.
Okay. So here we're going to apply Ohm's law. So V1 minus 10 divided by 1. So we're assuming all the currents are leaving the node. And for the second one, the one that's flowing through the 5 ohm, so it's going to be V1 minus the voltage at node 3, which is 0, divided by 5. Then the third one will be the one that's flowing through the 2 ohm, which is going to be V1 minus V2 divided by 2 equals to 0. So now let's write down the equation for the second node. So I'm assuming all the currents are leaving that node. So I have this current. Well, first of all, I don't need to assume anything here because I have a current source, and that current source is entering the node. So I can use it as it is, but I need to change its sign. But here I have this current leaving that node, and that current is also leaving the node. So let me start with the current that's flowing towards V1. So in this case, I have V2 minus V1 divided by 2 plus V2, the one that's flowing through the 10 ohm resistor, minus 0 divided by 10. Then I have a current that's entering the node, so it has to be a negative here, because we're assuming positive sign for the current leaving the node. And all of our assumption here, we're assuming that the current is actually, the currents are leaving the node, equals to 0. So now I have 2 equations, 2 unknown. So it's really good to simplify it. So if I simplify, I will get, for equation 1, 1 plus 1 over 5 plus 1 over 2, V1 minus 1 over 2, V2 equals to 0, or 1.7 V1 minus 0.5 V2 equals to 10. So this is the first equation. The second equation is going to be minus 1 over 2 V1 plus 1 over 10, 1 over 2 plus 1 over 10, V2 equals to 2. And this is going to give me the following equation. So clearly now I have two equations, two unknowns. So if I want to solve for it, I need to so I have two equations, two unknowns. So if I want to solve for it, I need to write it in a matrix form. So if I write it in a matrix form, I will end up with the following equation. So I need to write it this way. Okay. 10. Okay. I need to write it 10, 2 equals to 1.7 minus 0.5 minus 0.5.6. So 1.7 minus 0.5 minus 0.5.6 multiplied by V1 and V2. So if I invert this matrix, I will end up with V1 equals to 9.09 volts, V2 equals to 10.91 volts. So in order to invert this matrix, you need to actually apply, you can use your calculator, and in almost all of your calculators, you have the option for inverting 2x2 and 3x3 matrix. Is it clear, Shabab? Ahmed?
Doctor, can't I use cancellation method?
You can use cancellation methods.
Yeah, okay.
I just don't like playing with equations too much because it's much easier to make mistakes. So if you write it in the matrix form, then just invert the matrix, then everything should be simple. Okay, any other question? Is it clear, Shabab?
Yes, thanks.
Okay. Yes, sir.
Doctor, even if we have a current source that is going out of the essential node, we will put it as a minus, or we will put it as a plus?
No, if the current is leaving that node, we'll make it plus.
Yeah. Okay, so we make our reference if the current is leaving, so it will be positive and entering minus.
Yes, exactly. And that's the convention that we've been using so far.
Thank you.
Any other question? Omar, Saleh?
So, Doctor, V1 is the voltage at node 1, right?
Yes. V2 is the voltage at node 2.
Yeah, okay, thank you.
طيب Fahad?
Yes, Doctor. Can you see the two arrows under the resistor 2 ohm?
What about them?
Why are they not in the same direction? We assumed the first one to be leaving.
Yes.
And why didn't we continue assuming that it's leaving?
Okay, this is an excellent question because we apply KCL independently in each node.
So we assume each time. يعني.
Each time we assume that the current is leaving the node.
Thank you.
Okay, good. Okay, very good. So now let's solve this exercise. And this exercise, we are asked to use the node voltage method to find the current IA, IB, and IC. And then we need to find the power associated with the sources. So let's start with the first one. So we have IA, IB, and C. So let me start with Walid. Okay, what will be the first step, Walid?
Yes, first we count the essential nodes, and
Okay,
the circuit has to.
Yes, Walid.
Okay.
So I always like to have the circuit. Okay, very good. Yes, go ahead. Walid?
Yes, this circuit has two essential nodes.
Yes, which one?
The one in the upper left.
Okay.
And yes.
Okay, this one.
Yes.
Okay, this is one.
And in the lower.
Okay, great. So I need to set one of them as a reference. Which one do you recommend?
The lower one.
Okay, so the lower one is a reference. So I have, in this case, I have only one node voltage. So it's one equation, one unknown. Okay, very good. Adnan, can you help me write the node equation?
Yes.
Yes.
We first start with IA.
Forget about. Here's the thing, Shabab. Forget about what's required here. So you first write the node voltage equation, and then you find the node voltage. Then you go back and think about what you've been asked to find.
Yes.
Okay.
So V1 minus V0 over 10.
V1 minus 0. Here I will assume I will ignore 0.
Yes.
So it's over 1 over 10. Okay, good.
And V1 over 40.
V1 over 40.
And we have minus 3.
Okay.
And the last one is V1 minus 50 over 5.
And this one should be equals to 0. Excellent. So let me simplify it here. So if I simplify it, I will end up with 1 over 5, 1 over 10, 1 over 40, V1 equals to 13. So 0.325, V1 equals to 13. And this is going to give me V1 equals to 40 volts. So now I found the node voltage that I'm interested in. Hadi, how to find IA in this case?
We just have the voltage, so we just need to put IA is gonna be equal to V1 over the resistor.
So this is IA.
Yeah.
I don't agree with you.
This is by using the Ohm's law.
Yes, Ohm's law is going to be the potential difference.
V1 now minus 50.
50 minus V1. 50 minus V1. Because the direction here.
Oh yeah, we assume that's leaving before. Okay.
So V1. No, it has nothing to do with the assumption that it's leaving. So 50 minus V1
over 5.
divided by 5. And in this case, it's going to be 2 amperes. IB خلينا نشوف زياد.
Yes.
What is I?
Will equal 40 over 10, but in the opposite. Minus 4.
And this is going to be 4. Shabab. So the assumption that we are assuming that the current is leaving the node has nothing to do with the voltage that we found. So what we found here, we found the potential to be 40. So at this point, the difference between this point and that point is 40 volts. And again, here we have 50 volts. So the difference between this point and that point is also 50 volts.
But isn't the current going from the positive to the negative?
Yes, 40 minus 0 divided by 10.
Yes, so if it's going from the arc.
Okay, if it goes from the higher potential to the lower potential, it should be positive. Okay, I see, let's see, Ziad.
Yes.
اوكي من اللي هو انسر لا اي بي هو انسر اي بي.
Yes, me.
زياد you
Yes.
answered اي بي صح؟
Yes.
Okay, then ابراهيم.
For IC, it's 40 over 40.
It's 40 over 40.
Which means 1.
This is going to be 1 ampere. So we saw that the original question was asking us to find actually IA, IB, and IC. And we saw that, well, with if we use the node voltage, then we'll find the if we use the node voltage method, then we'll find V1, and from V1 we can apply Ohm's law. So all what we did here was applying Ohm's law. So we applied Ohm's law, and from Ohm's law we found the values of IA, IB, and IC. Okay, so now let's go to the second part, which is asking us to, I think, calculate the power. So we need to find the power associated with each source and state whether the source is delivering or absorbing power. So let's start with Abdullah al-Jariri.
Yes.
Yes. Let's start with the 50 volt source.
Okay. So we multiply the 50 by 2.
Okay.
It's minus 50.
Minus 50 multiplied by 2. And this is going to give me minus 100 watt. Is it delivering or absorbing? Power?
It's delivering power.
Okay, it's delivering. Okay, excellent. Now I need okay. I need the new name of the crib suit.
Yes, doctor.
Yes.
For the 3 amp, it's gonna be 3 multiplied with 40.
What about the sign?
It's negative. It's going from negative to positive.
Okay, so it's going to be 3 multiplied by 40, and this is going to give me minus 120 watts. So again, this one is delivering. Okay, very good. So now let's take it a step further. Let's apply again node voltage method here. شباب, okay. Yasser, question?
No.
Okay. So now if we apply the node voltage method, we want to apply the node voltage method and we want to find actually the power dissipated in the 12 ohm resistor. So this is the 12 ohm resistor. And we want to calculate the power dissipated in that 12 ohm resistor. So we need to find the node voltage. We need to use the node voltage method. And from the node voltage method, we're going to get the current passing through the 12 ohm resistor. And this current can be used to calculate the power dissipated in that resistor. Okay, who wants to start? I need to find new names. Okay, Yasser is there. He participated. Ahmed Al-Hamid.
We have to select the essential nodes.
Okay, what are the essential nodes?
In the corner, there are 4 essential nodes.
Okay, so this is the first one.
Yes, and the second one on the right. Yes.
Okay.
And this. Yes.
Okay.
No. Yes, this one. On the left and on the left.
Okay, so we have 4 essential nodes. In this case, all of them could be actually good candidates for being the reference point here. So I will choose, in this case, I will choose this one. Okay, I will write this one as V1, V2, V3. So the number of essential nodes are 4. So which means that I have 3 equations. Okay, very good, Ahmed. So let's look for.
Sorry for this disrupting, but can't we use the higher number of the branches?
They all have the same number. Except maybe V1. It's if you choose any of them, you should get the same solution. I would rather choose this one because it's connected to the voltage source.
Okay, thanks.
Okay. Good. Mohsen?
Yes. The first equation will be V1 minus 40 divided by 12.
Okay, so we start with node 1. So V1 minus
40 divided by 12.
It's not minus 40, it's minus 40.
Oh, okay, because okay.
Divided by 12. Then what?
Plus V1 P1 over 24.
25.
25, yeah.
Okay.
Plus V1 minus V2 over 20.
Okay.
Plus 5.
Plus 5.
Equal to 0.
Equals to 0. So if I simplify it, I will end up with the following equation. 0.173 V1 minus 0.05 V2 equals to negative 8.3. So this is the first equation. So the second equation, Muhammad.
In V2, you can say that V2 minus V1 over 20.
Okay, V2 minus V1 divided by 20. Okay.
And V2 minus V3 divided by 40.
V2 minus V3 divided by 40.
-5 minus 7.5.
-5 minus 7.5 equals to 0. So if I simplify it, I will end up with So now I have two equations. The last equation is okay. Let me find a new name. Talal.
Yes, V3 over 40.
Okay, I will try to write it here. So this one a little bit. So V3 divided by
40.
40. Okay.
And V3 minus V2 over 40.
Okay.
Plus 7.5.
Plus 7.5
equal to 0.
Equals to 0. So if I simplify it, I will end up with minus 0.025 V2 plus 0.05 V3 equals to minus 7.5. This is the third equation. So now I need to invert the matrix. So just fill in the coefficients. The coefficient from the first equation for V1 is going to be 0.173. For V2, minus 0.05. For V3 is not there, so it's 0. The coefficient is 0. Minus this comes from the second equation. So the second equation is the only equation that has all of the three variables in it. And the last one comes from the third equation. So I have V1, V2, and V3, and they are equal to 12.5, 7.5. So if I solve for them, I will get V1 equals to minus 10 volts. V2 equals to 132 volts. And V3 equals to minus 84 volts. Okay. I'm not done yet. This is not what I've been asked to find. So I'm asked to find the voltage, the power dissipated in the 12 ohm resistor. So Yasser, what do you think?
Yes, we should say that V1 minus 40 over 12.
Okay, this is gonna give me the current. So the current passing through the 12 ohm resistor, V1 minus 40, 12, which is 30 divided by 12. This is going to give me 12.5 amperes. So the power will be I squared multiplied by R. So I squared will be 2.5 squared multiplied by R. R is 12. So this is going to give me 75 watts. Okay, question? Ahmed Al-Hamid, Omar, questions?
Yes, doctor. Why do we use minus 40? for the battery?
Because here, look into the polarity here.
So because it's inverted?
Yes, because it's inverted here. Here we have positive because the polarity is like this.
So it's always positive up and negative down, or what?
No, it depends on if it's positive up and negative down, then it means that this point, let me call this one X, has higher potential than Y. If it's this way, then X has lower potential than Y. In this case, X has lower potential than Y. Okay? If it's not clear,
Yes, thank you.
we'll discuss it later. محسن.
دكتور هنا ما حدد اتجاه التيار، كيف عرفت انه from V1 إلى ال 40؟
It doesn't matter actually, because you're gonna square it.
اوكي بس اذا ابغى الفاليو حق الاي 12 اوم.
It turns out that our assumption is correct because we got a positive value.
Okay.
So here we assume that the current is going from V1 to the 40 volt. And we got a positive value, which means that our assumption is correct.
Okay.
Very good. Okay, now let's apply node voltage method with dependent sources. So we'll see that if you have dependent sources, the application is going to be exactly the same. The only difference here is we need to add an extra equation. And this extra equation is going to account for the fact that we have a dependent source. So this extra equation is known as constraint equation. So let's apply node voltage method here to find the power dissipated in the 5 ohm resistor, which is this one. So in order to do that, again, we're going to use the same approach. Looking for new names, Shabab. Okay, the participation is here. Hamd al-Swalib. What will be the first step?
First, we should count the essential nodes.
Yes. How many?
Three.
Exactly. So we have 3 essential nodes. Oops. So I'm going to choose this one as the reference one. I have V1 and V2. So NE is 3, so it means that I have to use two equations. Okay, Munir, can you give me the first node equation?
V1 minus 20 over 2.
V1
minus 20 over 2.
Okay.
V1 over 20 plus.
Okay.
V1 minus V2 over 5 equals 0.
Okay, excellent. So if I simplify it, I will get 0.75 V1, 0.2 V2 equals to 10. So this is the first equation. So for node 2, let me find طيب أحمد نافع
Yes, V2 minus V1 over 5.
V2 minus V1 over 5.
V2 over 10. And V2 minus 8 I naught over 2.
Okay, V2 minus 8 I phi divided by 2 equals to 0. So if I simplify it, I will get minus 0.2 V1 plus 0.8 V2 minus 4 I phi equals to 0. And this is the second equation. So now here, notice that the fact that I have dependent source added an extra equation. So I need to relate I phi to V1 and V2. So how to do that? Okay, let me look for a new one. Adnan?
Yes, doctor.
Yes. How to write an equation of I phi in terms of V1 and V2? الحميداني عبد العزيز. عبد العزيز حمداني. You muted عبد العزيز. طيب. Okay. Yes, you were muted.
For the equation, we can V1 is equal to 10 plus 0.2 of V2 over 0.75. 0.75.
Not really. So I phi will be like this. From Ohms Law, from the definition of I phi here, it will be V1 from Ohms Law minus V2 divided by 5. So if I simplify it, I will end up with V1 minus V2 minus 5 I phi equals to 0. And this is going to be the third equation. So now I have three equations, three unknowns. I can easily solve for that. So I write it this way, 10, 0, 0, 0.75, 0.2, 0, minus 0.2, 0.8, minus 4, 1 minus 1, minus 5, multiplied by V1, V2, I phi. So V1 equals to 16 volts. V2 equals to 10 volts. I phi equals to 1.2 amperes. So now I found V1, V2, and I phi. So I need to find the bar dissipated in the 5 ohm resistor. So the bar dissipated in the 5 ohm resistor, I know the current, which is I phi. So the bar will be I phi squared multiplied by 5, which is 7.2 watts. Okay, you see that the only difference that a dependent source add to the circuit, the only complication that the dependent source added to the circuit was introducing a new constraint equation and a new equation that relates the variable of the dependent source to the node voltages. So if, for example, this dependent source was, if it was an independent source, then we'll end up with two equations and two unknowns. But since we have an independent source, we added an extra equation that accounts for the fact that this dependent source depends on a current that flows from node 1 to node 2. Okay. So let's try to solve. Yes, sir.
I did not really get how did you write the third equation in the matrix, or the third equation.
Okay. You agree with me on this equation, right?
Yes, I agree.
Okay. If you multiply both sides by 5,
yes,
and you move the term with I feed to the right-hand side, you should end up with this equation.
Yes, thank you.
Hassan, yes.
Yes, Victor. First, we specify the essential nodes, and we have 3 nodes, essential nodes.
Yes. Oh, you're talking about this one.
What?
You're trying to solve exercise 4.
Yes.
Oh, okay. That you're asking a question. Okay, then hold on a second. Okay. So in this exercise, we're asked to find the essential to find the node. We're asked to use the node voltage method to find the power dissipated to find the power associated with each source. So we have 3 sources here, 2 independent sources and 1 independent source. So yes, go ahead, Hassan.
Yes, we have, like we said, 3 nodes, 2 in the upper, yes, V1 and V2, and the reference, the ground.
Okay, good. So the first node equation is what, Hassan?
V1 minus 50 over 6.
Okay.
And V1 minus V2 over 2. And V1 over 8 minus 3I1.
Okay, this is the first equation. So if I simplify it, I will end up with 1924 V1 minus 1 over 2 V2 minus 3I1 equals to 25 divided by 3. This is the first equation. Munir, second one. V2.
V2 minus V1 over 2.
Okay.
V2 over 4. Minus 5 minus 3I1.
Minus 5 plus 3I1.
Oh, sorry, plus.
Equals to 0. And if I simplify it, I will end up with V1 3 over 4 V2 plus 3I1 equals to 5. This is the second equation. So the last equation that I need to add is the equation that relates I1 to the node voltages. And Ziad.
Can I go to the pictures? V1 minus 50.
It's 50 minus V1 divided by 6. or in this case, you will get minus V1 or plus V1. V1 plus 6I1 equals to 50. This is the third equation. So I have three equations, three unknowns. So I just write it in the matrix form. So in the quiz or in the exam, so you have to show me how to write it in the matrix form. Then you just solve. You just solve it using your calculator. So I'm not interested in how you invert the matrix. Just leave it to the calculator. But you have to construct it in a matrix form. So in this case, I know what you insert in your calculator. Okay, if you invert the matrix, you get 32 volts, 16 volts, and I1 is 3 amperes. So remember, you're not asked to find V1, V2, and I1. You're asked to find the power associated with each source. So let's start with the 50 volt source. So the power of the 50 volt source is going to be minus the current that's flowing, which is minus I1 multiplied by 50. So I1 is 3, 50, which is minus 150 watts. The power of the independent current source, which is the 5 ampere. The voltage across it is V2, which we found to be 16. And the last one is very important here. So what is the voltage across that independent source? Is going to be V2 minus V1. So the power of this one is going to be the current of the current source. And we're assuming that here it's much easier to assume, or you can assume in any direction you want. So we assume that the power is, the current is flowing from the positive or from the higher potential to the lower potential. So in this case, we have V2 minus V1. And if we substitute, the current is 3 multiplied by I, which is 9. V2 minus V1 is negative 16. So we end up with minus 144 watts. So clearly, all of these sources, they deliver power. So all sources, because the power is negative, so they are, all of them, they are delivering power. Okay. Hadius.
Doctor, there is a typo error in the matrix. There is no V3.
Excellent. It's I1. Thank you. So now we discussed the general case of the node voltage method. Then we took it a step further to include the dependent source. We saw like the inclusion of the dependent source does not complicate the problem. It only adds some sort of add an extra equation that we need to account for. Now let's consider what happens if we have some special cases. So one of the special cases here is this one. In particular, in this case, we have a voltage source. First of all, we have three node voltages, three essential nodes, V1, V2, node 1, node 2, and node 3. So we chose one of them to be the reference point, which is the one at the bottom. And we have two equations, presumably two equations and two unknowns. But pay attention here that we know the voltage at node 1. We know V1 here because we have a voltage source that's connected between two essential nodes. So if we have a voltage source that's connected between two essential nodes, then the problem is simplified because one of the node voltages will be given. So here you only ask to, the only thing that's missing is V2. So V1 equals to 100 volts. So it's in parallel and it's connected between two essential nodes. So I'm only missing one node voltage. So the problem is simple now. So it's going to be V2 minus 100, applying the node voltage method, divided by 10, plus V2 divided by 50, minus 5 equals to 0. So V2 is 125 volts. So let me ask you this question. So what is the value of the voltage source? It's 100 volt, right? Why am I getting 125 volts? If you have a battery in your circuit, can you get a voltage greater than the voltage of the battery? The answer is no. You cannot. This will set the highest voltage level. The reason I'm getting 125 here is the fact that I don't only have a voltage source, but I also have a current source. So the current source has some added voltage associated with it. And this will cause the voltage to be greater than the voltage source. Okay, the last part that we want to talk about, and we will actually defer the analysis. We have 3 minutes. So let's see. We have the concept of sober nodes. Okay, we'll discuss it inshallah tomorrow. We'll discuss the sober nodes, and then inshallah next week we'll start with the mesh current method. So any question? Any question, Shabab? Yes, Ahmed.
Doctor, could you please send more samples of quizzes?
I taught the course once, so how am I supposed to give you more quizzes?
Again?
I taught the course once last semester. So this is my second time teaching the course. How am I supposed to give you more quizzes?
Okay. Thanks.
Amar?
So Doctor, we're supposed tomorrow to send you through WhatsApp.
Yes, right? Yes. Okay. Here, everybody, pay attention. So for tomorrow's, here's the thing. So because the quiz is going to be written, so I'm going to ask you to write your response. So immediately after the quiz, you should take a picture and send it by WhatsApp to ensure that it's a WhatsApp business account, so it has it has a response, it has a default message. So make sure that you got the right number. You can send me anything now, and you should get an automatic replay message. So you should, what we're going to do is we're going to or like immediately after the quiz, because you're going to write your response immediately after the quiz, I'm going to ask you to, you have 3 minutes, I'm going to ask you to take a picture of your solution, send it by WhatsApp. Then you will have 24 hours to upload, to scan it in a better way and upload it on Gradescope. But I'm gonna check the WhatsApp picture. I'm not gonna get the WhatsApp picture. I'm gonna check if the WhatsApp picture matches the file that you uploaded. Okay.
Doctor, do you mean we have to send the picture?
So some people are raising their hands, so I cannot.
Okay.
Abdullah.
كويز بكرة بيكون similar للسامبل اللي دكتور اللي أرسلته.
Yes, but not the same question.
Yes, of course. And ناخذ الحصة كاملة بكرة ولا جزء منها؟
Most likely no. No, it's the only thing that might take a while is making sure that you guys have the correct setup. Other than that, the quiz should not take more than 10 to 15 minutes max.
تمام.
Abdul Aziz.
Yes, doctor. So if I'm having right now, I feel like sick, and maybe I can have a medical excuse. Can the quiz be delayed for me?
It has to be through student affairs.
What about if the medical excuse from the Ministry of Health?
You should verify it with the student affairs. I don't want to open this door.
Yes, I understand, but I'm mentally and physically not able to study and understand well.
It has to be Abdul Aziz through the student affairs. Again, the summer semester is optional. So it's not a mandatory semester, but it has to be for the student affairs. I cannot accept any excuse, any personal excuse. أتمنى لك الشفاء. لكن it's something that we need to. It's something that I cannot open this door.
Okay. Yeah, I understand.
Mohammed?
Yes, Doctor. After sending the picture in the WhatsApp, is it okay if I rearrange it in a new piece of paper just to be suitable for the eye without changing anything?
No. You should scan it as it is. So you should solve the quiz as if you are asked to submit it to as if you are asked to submit it immediately.
Okay, thank you.
Okay, good. Talal?
Yes, doctor. Is it okay to use a board? Because I write on a board, not on paper.
Board? What do you mean by board?
Board.
Sabura.
Yes, sabura.
No, you have to write it on a piece of paper.
Okay.
Omar?
The quiz is going to be on Blackboard or on Teams?
The quiz what?
Is going to be on Blackboard or on Teams?
No, the quiz will be something like the one that I sent.
Yeah, I mean, where
You'll
we
see
can
the
find it.
question. You see the question like this on Blackboard.
Ah, so
And you
it's in
need to.
Blackboard.
What's that?
It's in Blackboard, right? We will find
Yes.
it there. Okay, thank you.
Yes. Hadi.
Doctor, how much time that we dedicated to solve the code?
I don't know. It should not exceed 15 minutes. I haven't written the question yet.
Oh, okay. It's all right to use a notebook, right?
Notebook.
دفتر.
Try to avoid it. Use blank space, or just scrub the tear down the page and use it. So I don't want to see any notes, any handouts, any notebook on your desk.
All right.
So we're making it easy. I'm giving you partial credit by asking you to show me the detailed questions. So I'm expecting you to. This requires taking extreme precautions to make sure that everybody has the same chance.
All right.
Yeah, Salman.
Can I solve it by iPad and
No.
submit it?
iPad is allowed only for me. Okay. All questions about this. Okay, very good. طيب. Yes, Ali.
Doctor, I
Yes.
came late by 6 minutes or 7, I think, because previous lecture is being late, so the quiz started late.
Oh, okay, okay. Don't worry about it.
Okay, thank you.
Okay, no other questions? طيب, we'll see you inshallah tomorrow and good luck.